The current Midtown Tunnel between Norfolk and Portsmouth is one of the most heavily traveled two-lane highways in the Commonwealth of Virginia. The second Midtown Tunnel will increase capacity, reduce congestion, and provide safe and efficient operations for decades to come. The Skanska-led design-build team, SKW Constructors, is comprised of a joint venture between Skanska USA Civil Southeast, Kiewit Infrastructure Company, and Weeks Marine. They are supported by a design team of Parsons Brinckerhoff and Volkert & Associates. A significant example of this team's previous experience in immersed tube construction is the world's widest underwater vehicular tunnel, the Fort McHenry Tunnel in Baltimore, constructed by Skanska and Kiewit and designed by Parsons Brinckerhoff. The Elizabeth River Tunnels project can be separated into 5 distinct areas of construction. The second Midtown Tunnel itself, which was built using immersed tube tunnel methods, the Norfolk approach, the Portsmouth approach, and an extension of the Martin Luther King Expressway, which will provide a direct high-speed connection between US 58 and the Midtown Tunnel and I-264 and the Downtown Tunnel. And finally, rehabilitation of both the eastbound and westbound tubes of the Downtown Tunnel and the existing Midtown Tunnel. Although the majority of the immersed tube tunnels constructed in the United States have been steel shell concrete tunnels, like the Fort McHenry or the existing Midtown and Downtown tunnels, concrete tunnel elements were fabricated for this project, both for their cost savings and flexibility of design. Tunnel fabrication involved the construction of 11 rectangular reinforced concrete tunnel elements, with temporary bulkheads installed on each end so the tunnel elements would float. The elements were fabricated at a dry dock facility in Sparrows Point, Maryland, and then towed down the Chesapeake Bay to the job site in Portsmouth, where they were safely moored and prepared for immersion. Float out of the 11 tunnel elements was completed in 2 phases, Spring 2014 and Spring 2015. Once delivered to the project site in Portsmouth, 2 to 3 tunnel elements were outfitted simultaneously at the Virginia Port Authority's PMT dock. Prior to placement of the elements in the Elizabeth River, trenches were excavated on land and at the bottom of the river. 1.5 million cubic yards of sediment was excavated, with approximately 10% being disposed of at an upland facility and 90% approved for ocean placement. For the land excavation, existing abandoned timber piles and shoreline debris were removed and a steel-supported excavation system installed. Ground within the system was removed to make way for the new tunnel. The installation of the immersed tunnel elements required dredging a trench, using a dredge barge and crane with clamshell bucket. The trench at the bottom of the river is 55 feet wide and was filled with a minimum of 2 feet of gravel leveled to the proper grade using a screed barge. To complete the screed foundation for one immersed tube required 3 setups. Placing the tunnel elements was performed using a lay barge, a special catamaran barge with placing girders spanning the opening between the barge hulls. The lay barge was capable of receiving, supporting, ballasting, and lowering the negatively buoyant elements to the bottom of the river. To achieve negative buoyancy, water ballast tanks were installed in each tunnel element. Removable survey towers, mounted on the outboard end of each element, combined with GPS technology, were used to control the horizontal and vertical placement of each element during immersion. Each tunnel element has a thick rubber seal attached to its inboard end. It was compressed against a steel plate on the outboard end of the receiving element, and when water was pumped out of the joint chamber between the concrete bulkheads, it created a watertight seal between the new and previously placed elements. Each of the 11 tunnel elements was placed sequentially on the bottom of the Elizabeth River, beginning in October 2014 on the Portsmouth side and moving toward the Norfolk side. Elements were placed at a rate of about 1 per month, with the placement of the last element occurring in July 2015 on the Norfolk side. Approximately 2.5 of the elements lie within the federal shipping channel of the river. Backfill of the installed immersed tunnel required 3 distinct backfill operations. Immediately after an element was immersed, the locking backfill was placed first to prevent any horizontal movement of the element. The tunnel elements were then covered with ordinary backfill designed to provide a protective cover over the tunnel. The final layer of backfill consisted of armor stone, placed to protect the tunnel from scour and from dragging ship anchors or other possible marine impacts. Backfill operations were performed using two methods: placing the backfill with a specialized fill barge equipped with trimmy pipes and a clamshell bucket. The interior of the new tunnel was determined by the required traffic clearances, requirements for ventilation, fire protection, and evacuation. A longitudinal ventilation system based on jet fans was installed and resulted in the smallest cross-section and the lowest future maintenance costs. Fireproofing, mounted directly to the tunnel walls and ceiling, coupled with a sprinkler deluge system, will provide protection from potential fires inside the new Midtown Tunnel. The design of the new Midtown Tunnel called for an egress corridor to facilitate the rapid evacuation of the tunnel in the event of an emergency, accessible from the main tunnel by fire-rated doors spaced 300 feet apart. The Norfolk Approach roadway connects directly with the existing westbound lanes, thereby minimizing work within the existing interchange. The vertical alignment required to meet the Norfolk Approach necessitated an expansion of the current peninsula by installing some earth fill in the river. This required expansion was kept to a minimum. The access road to the existing tunnel vent building was also relocated. The Portsmouth Approach roadway yields a simple curve that fits within the existing right-of-way. The Port Access Road was relocated permanently, and other temporary relocations of roads and railways were required during construction, particularly within the port property. The relocation of the access roads and other approach roadway work resulted in some minimal right-of-way impacts in Norfolk and Portsmouth. The Martin Luther King Expressway extension and interchange will provide a direct freeway-to-freeway connection between I-264 and the Midtown Tunnel. The Elizabeth River Tunnels project and its 5 distinct areas of construction, the new Immersed Tube Tunnel, the Norfolk Approach, the Portsmouth Approach, the extension of the Martin Luther King Expressway, and the rehabilitation of the Downtown Tunnel and the existing Midtown Tunnel represent a smart growth investment, an investment in safe traffic operations, preventive maintenance, and rehabilitation that will keep the area's roads and tunnels running smoothly and preserve both the quality of the assets and the quality of service provided to the traveling public.